In this question, we are told that 3 ropes are tied together. 2 of the ropes are anchored to the wall, and the third rope is pulled with a force of 100 newtons. And we want to know what is the magnitude of the tension force in each rope. Now, the first thing you want to do is draw a free body diagram. We will start by drawing a point, which represents the point where all the ropes are tied together. Then we will draw the tension forces T1 and T2, and we will draw the pulling force of 100 newtons. And notice this force is at an angle of 30 degrees below the x-axis. Now, because this vector is at an angle, you have to split it up into its x component and y component. The x component is tx and the y component is ty. And in order to answer this question, we have to figure out what is tx and what is ty. And we can do that using vector addition. If we add tx and ty tip to tail, we can form a right angled triangle where the resultant is the 100 Newton force. And then we can use trigonometry to solve for tx and ty. We have to recognize that tx is the adjacent side, ty is the opposite side, and the 100 Newton pulling force is the hypotenuse. Let's start by solving for ty. We can use the sine function, since sine theta is equal to opposite over hypotenuse. All I have to do is plug in my values for the opposite and hypotenuse sides, rearrange and isolate for ty, plug in the value for the angle, and we find that ty is equal to 50 newtons. Now let's solve for tx. We will use the cos function because cos theta is equal to adjacent over hypotenuse. All I have to do is plug in my values for the adjacent side and the hypotenuse, rearrange and isolate for tx, and then plug in my value for the angle, and we find that tx is equal to about 86.6 newtons. Now that we know tx and ty, we can move on to making our Fnet equations. And now what's difficult about this question is that you have to recognize that we have forces along the x-axis and along the y-axis. And that means we need to solve for an Fnet x, the net force along the x-axis, and an Fnet y, the net force along the y-axis. Fnet x is going to be equal to tx minus t1. T1 is negative because it's a vector that points to the left, while Fnet y is going to be equal to t2 minus ty. Ty is negative because it's a vector that points down. And now that we have our Fnet equations, we can solve. Let's start with Fnet x. The key to answering this question is recognizing that none of the ropes are moving. That means the net force is equal to 0. So we can replace Fnet x with 0. Then all we have to do is rearrange for T1, and we find that the tension in rope 1 is 86.6 newtons. Now we can do Fnet y. And again, none of the ropes are moving along the y-axis, so we can replace Fnet y with 0. Then all we need to do is rearrange for T2, and we find that T2 is equal to 50 newtons. And that's the answer to this question. This question challenged you to use free body diagrams, make Fnet equations, and know when the net force should be equal to 0.